see the Dijistra algorithm. So this is also single source shortest path. That is, we have a source S and we need to find the shortest path to all the nodes from the source S, like 1 2 3 4 nodes and 5 6 7 8 9 nodes. So first the immediate nodes are considered. There is 1 2 3 4 node and the weights are drawn with red color and the path is with green color, and first we find the immediate nodes. That's the first set. So then we add one more extra node, say like the fifth one. So we find the shortest one there, just accessing the edges from the fifth one to the 1 2 3 4. We find shortest one. Then we add the sixth one. Then we find the shortest edge there. The shortest edge is being marked with the double edge, that's with red and green. So then we find the seventh one, the shortest edge, eighth one, shortest edge, and then ninth one, the shortest edge. So this is how we incrementally develop a algorithm to find the single source shortest path. So single source shortest path, that's digital algorithm, is a greedy algorithm, whereas there can be dynamic algorithms. Greedy algorithm has an optimal substructure, which means a global solution lies in following the optimal solutions at local points. So whereas in the dynamic programming it's not the case. So let's see the difference between greedy and dynamic programming, and how Floyd Warshall is using a dynamic programming for also shortest path. So see, the optimal structure is equal to global structure in the sense the single source, if they say the rounded thing is the source, we need to find the path from the source to all the nodes, the shortest path. So say I have drawn the shortest path. The path alone is represented in the top with the red color. Say if you disconnect any of the edges, that graph will be disconnected. That's it. It's like a spanning tree, and the path to any of the node will be cut. So this is the optimal global structure. Optimal structure tending to global, which means if you find the shortest path to any of the nodes, it should lie the shortest path to the node that is beyond that node. So whereas in the case of dynamic programming, it's not the case. Optimal substructure is not equal to global substructure. So however, we need to find source first path for all the nodes. So it's not all source shortest path. So if we take a subset of the edges, subset of a nodes, say the number 4, then we keep on adding that. Then there's something called overlap. Overlap means it will form a spanning tree every path, single source. Ultimately everything clubbed together, it will form a spanning forest that will cover all the minimum distances in a graph, connected graph. So maybe the shortest path to all is not in the single source, a single spanning tree, but the forest will cover everything. Whereas this is the simulation of a digital algorithm in the browser. So I have just used a visual.go.net browser. Thank you.